You know, my friends, there's nothing wrong with a little nostalgia, a little thinking about the good old days, whether to you that was last year or last decade. But, you know, you can't live in the past, and that goes for your Cisco routers and switches too. And if your timestamps reflect an era that's long gone, say March of 1993, it is time to get another time source. I don't know why Cisco routers and switches default to this month and date. I've asked 5 different people and gotten 10 different answers, so I don't really ask anymore. I'm sure since I'm asking this on a video, someone will give me the definitive answer. But your clock is liable to say March 1993, and that is not good. Now, we can set the local device's time with clock set. And I'm going to show you this. Let me show you, see if the logs are still, actually the log would still be there. Let me do a quick show log here. Now, at the end of the syslog message, when we're going through the log, we noted that the early messages, the ones we're looking at now, had a time of March 1st, something something, and then all of a sudden the ones at the end had April 1 something something, and I did tell you that those two videos had been done, you know, within 24 hours of each other. And that's because for one of them, I had done a write erase and didn't bother setting the clock because I didn't need it for that particular lab. And I did want it for syslog, obviously, when we're talking about the timestamps, that kind of thing. So what I did there just for one router is run the clock set command. And this can drive you a little crazy for one reason. You do a conf t and your clock set, and you're thinking, okay, what's the syntax? I'll use iOS help. And you get unrecognized command, and you get, maybe just for a moment, you get that, I've been doing this for 47 years, and it's always been there. Well, actually, it's never been there. You do have to set the clock set command at the enable prompt itself. So, clock set, and we'll just go ahead and set it again here. Won't hurt us a bit. 090900, then your month or day, and it's April 1, 2015, and you're done. That's it. And there's your clock update message, a little syslog message, very helpful. System update, system clock has been updated from this particular time to this particular time. And really all is well. We've got a couple of commands we can use to fine tune that, and they do have to be run here. And it's clock time zone and clock summertime. Now with clock time zone, name of time zone. Well, I don't know the name of my time zone. Actually, I do. But iOS help, you know, you get so used to it showing you at least a list of numbers or port numbers or something or other. And it's just not going to tell you what the time zone is. You got to get that on your own. And as I show here, the clock time zone command does not list every time zone in the world. Actually, it doesn't list any of the time zones in the world. It also doesn't show you the coordinated universal time, the UCT, and that's not switching the letters around. Coordinated universal time is UCT. So you got to know yours. Now, I live on the East Coast of the United States, so I would put in EST for the time zone. Then it's going to ask you for an offset. Let me show you that. EST. And it's just hours offset from UTC, and it's minus 23 through 23. And that's quite a range. So I would put in -5 for that. Now for your personal reference, and I'll put this URL in the description on the video site that you're watching this on as well, but Wikipedia has a great page listing all the time offsets, and there are other ones too if you're anti-Wikipedia. So just go out there on the web, grab your time offset, and put it in there. Now let's look at the summertime command while we're here too. Looks like mine would be -5, but the time clock summertime command. And then it's name of time zone in summer, which you have to get. I know mine is EDT. And then it's going to say, do you want absolute summertime or a recurring summertime? And I would just go with date there most likely, and then date to start, month to start, or you could just do recurring. And then it's week to start, first week of the month, last week of the month. You have to set the actual summertime, the actual time zone. Now, truth is, these are good commands to know. You know, set, clock time zone, and clock summertime. But you're probably not going to use these in your network because it's very difficult to keep the time synchronized between your devices when you're setting it manually on all your devices. And this is so important when it comes to timestamps because we've come a long way, but I've been in more than one network over the years where you've got two devices and you're looking at the timestamps, you're trying to figure out what's going on, and literally one of the routers says, it's 3 o'clock last night, and this other router says, well, it's 1993. And it's impossible to figure out what's going on, or much more difficult, I should say, when our network time is not synchronized. Now, there are other reasons that we need synchronized network time beyond timestamps. Digital certificates run, on synchronized time. You've got to have the correct time there. There are some other things you need that correct time for as well. And that's when the network time protocol comes in. Because again, syncing the time throughout our network, allowing our routers and switches to have a central time source is so important. Our syslog timestamps then have accurate and synced time. That makes troubleshooting a lot easier. Synced time is important again for digital certificates. And if you're using any kind of accounting in your network, accurate and synced time is a necessity. You have not lived, and I've been there. Thankfully, I wasn't in charge of it, but you haven't lived until a department gets a billing for 67 days usage of a network resource, and it was a 30-day period. And it happened because the time got unsynced somehow. So the network time protocol, what it does, it allows us to specify time sources for our devices, whether that time source be another router in the same network or an external time source. Now, at the very top of the NTP hierarchy are stratum 0 devices. Sounds kind of threatening. And they are typically atomic clocks. Now, you can't configure a router in your network to get its time directly from an atomic clock. It would be cool if you could, but you can't. Now, the number that follows stratum in the name in any non-stratum 0 device indicates how many hops the device is from a stratum 0 device. And you thought you were done with hops and RIP, right? Well, stratum 1 servers, they're generally referred to as time servers. And we can configure a Cisco router to get its time from a stratum 1 device. Now, it is strongly recommended that your network's outside router, the one facing the internet, so to speak, it should get its time from a public NTP time server. Now, those IP addresses change over time. So what you want to do if you're setting this up, you just run a search on the term public NTP servers, and you can get a list of the latest IP addresses. You can't block UDP port 123 on that one or other routers in your network, because that's the port NTP uses. Remember the syslog messages I was talking about? You put an ACL up that's blocking NTP all of a sudden, and you're going to get some messages, and we don't want that. Now, Cisco routers can serve in 3 different roles in NTP. They can be servers, they can be clients, or they can be peers. They can also depend on NTP broadcasts or multicasts for the correct time. Now, the NTP server-client relationship, it's pretty much what you'd expect from any server-client relationship. The NTP server, or the master in this case, just says, hey, here's the time, and it sends the time to the client. Clients accept the time sync message from the server, set their internal clock accordingly. Clients do not send NTP time sync messages back to the server. Now, we are not limited to that traditional server-client relationship with NTP. We can also set up what we call NTP peers, and they will send NTP messages to each other, and either peer can send time sync messages to the other. It's commonplace, although not the only way to set up NTP, is that you have one device bringing in the time, so to speak, from the outside, and then you set up peerings inside your network. There is no one-size-fits-all solution for NTP, but that's one good way to do it. Now, about that broadcast and multicast mode, we can choose to run NTP in those as well, and basically your time server in your network is just broadcasting or multicasting NTP messages. It's basically yelling out the time and depending on everybody else to hear it, which of course the clients have to be able to get those broadcasts or multicasts, or we would be wasting our time. I always see, what I see much more of as far as NTP goes, I'm not saying broadcast mode is the wrong one to use, but I do see a lot more server, client, and peering than anything else as far as the setup goes. It is highly recommended that, again, that an NTP public time server be used as your NTP master time source. Should you choose to use one of your network routers as the NTP master, you need to use NTP authentication and or ACLs to prevent routers from outside your network syncing up with your NTP master as its public time server. We don't want that. We're going to configure a lab in the next video. We're not going to go through every possible scenario with NTP, but I want you to see a couple of them. And what we're going to do, our multi-layer switch is going to be our time server. It's going to be our NTP master, and router 3 is going to be configured as a client of that server. And we will start that lab at the beginning of the next video.